Hello everyone, my name is Helena, and on behalf of Angela, Christine, and Esteban, today I will be talking about mapping geospatial data with Geopandas. So briefly, we will go through the background of the library. We will mention why to use Geopandas, and we will explore the main functions and usage of Geopandas, including the special Geopandas terminology, installation, and functions such as plotting maps, calculating areas and distances, and managing projections. In the end, we will finish with an example of using choropleths, a particular type of geospatial map, to solve particular hypotheses and questions. Geopandas is an open source library which is built on top of pandas to include geospatial data. It reads and writes particular types of files, shapefiles, and measures areas and makes maps. Geopandas are a cartographic plotting library for 90% of use cases, and it's probably the easiest library to begin with. It solves the most fundamental peculiarity of geospatial plotting, and that is, how do you plot a sphere, which is our Earth, onto a flat surface or a map in an accurate way? It is compatible with Matplotlib, and it's built on top of pandas. First, we need to know what we work with. And in Geopandas terminology, we work with a geodata frame. That is a pandas data frame with an additional column with geometry. So a geodata frame has normal pandas data frame columns such as index and some sort of data. But it also has a particular geometry column that includes geometries, points, or polygons. And GeoSeries can contain any geometry type and stores information about the particular projection or a coordinate reference system, otherwise known as a CRS. A geometry is a vector or a column in a data frame that's used to represent points, polygons, and other geometric shapes. A polygon is an outline that consists of closed and connected points which are identified by coordinates in a particular coordinate reference system. A shapefile is a particular type of Geopandas geodata frame file. A projection then is a particular type of method of how an area gets flattened into a 2D map. And a choropleth is a particular popular type of maps that uses different hues to color polygons as the way to represent data levels. Another name for a choropleth that's sometimes used is a heat map. To install Geopandas in Colab, first we need to install different prerequisite packages. We have done this before because it takes some time, but you can reuse this code if you decide to work with Geopandas in Colab. To install Geopandas in Spider, you can use Conda. Simply open the console and run this line. We have also here imported Pandas as PD, Matplotlib PyPlot as PLT, and Geopandas as GPD. And now we will explore the main functions of Geopandas by exploring the voting districts in Germany, and later the results of the 2021 elections. You can access the data that we use, or the shapefiles that we use to plot this map, on a link that is provided in the Colab. First, we have imported files that we have downloaded, and we don't show it here, but they're imported in the Colab file. You can see that the map consists of several different types of files. One of this is a SHP file, which is a shape file. And these other files provide different information about the geometries that will be used to plot. So when you download shape files, you can expect that you will have a zipped file or something of a sort with different types of data formats inside. Then we read the file. We simply input the gpd.read file, and we reference here the SHP file. And we also check in this line whether or not the data frame that we have just read is a geodata frame. And it is. And to see what a geodata frame looks like, we can see that it looks like a normal data frame. It has an index. Here it has the number of the voting district and the code for the federal state. It has a column with the names of the federal states and the names of the voting districts. But it also has this peculiar geometry column that consists of polygons. The main function to use to plot polygons in Geodata Frame is geodataframe.plot. And we will use it to plot this map of Germany's voting districts. And here it is. These small shapes that have white borders represent or correspond to the polygons in the geodata frame that we have just read. This data frame can be used for different calculations that can be helpful when we're trying to answer some different types of questions. For example, we can calculate the area or the size of each voting districts using the area function that we call on the entire data frame, and we can then plot it. The resulting plot shows the same voting districts, but now colored depending on their size, and we can see that the voting districts that are the darkest in these maps are the smallest, and the ones that are the lightest are the biggest. We can also use the same area shading, but plot only the boundaries of each district, in case we find this map too cumbersome. And we do that by calling another function on the geodata frame. It is the boundary function. And here we have the same areas, but instead of the entire polygons being colored, we only have the borders of the polygon colored on the map. Another thing we can do, we can plot and calculate the geographical center of each polygon. We do that by calling the centroid function on the geodata frame. And the centroid function actually collapses all the polygons into points on the map. Centroids are useful to calculate distances between points in the map. For example, we can calculate how far from Berlin are all the polygons or all the voting districts in Germany. First, we find the centroid for Berlin. We then use the distance function to calculate the distance between the centroids in the GeoGermany data frame and Berlin Mitte. And then we output the table. And we can see that the result here are distances of each voting districts to Berlin. We can also work with multiple geospatial data in Geopandas. Imagine we want to see where the headquarters of German companies are located. And we can simply overlay that information over our existing map of Germany. We have previously imported the file which contains information on the headquarters of notable German companies and the latitude and longitudes of their headquarters. And you can find the original data on the link provided. We will read this data frame, and we will plot a simple scatter plot and matplotlib. From this plot, you can already see shape of Germany, and you can see that the headquarters of notable companies are not distributed evenly. So there are more companies on the west and south of the country as opposed to the center or east. And we can now try to plot these two plots together, the map of Germany and the scatter plot of companies. However, we were unsuccessful. We have the map of Germany here in the top and our scatter plot here somewhere in the bottom. That means we got our projections wrong. We can check what is the projection of our map of Germany using the .crs. We see here that there is a particular coordinate reference system that has a particular number, 25832, that is used in Europe between 6 degrees and 12 degrees and includes Austria, Belgium, Denmark, Germany, and so on. And we can now try to check what is the projection of the data on companies. And we get an error. It says that this data frame has no attribute coordinates reference system. That will mostly happen with the data you download in the wild, particularly if you create a CSV or a data frame on your own. It will not have a projection that is immediately set. To fix this, we need to change the projection of our company's data frame. For this, we will need some other packages that we have previously loaded in the Colab file. And we will convert the company's data frame into a geodata frame. To do this, we just need to call the Geodata Frame function, a GPT Geodata Frame function, on the company's data frame. And we need to specify where the geometric data is. And in this case, it is in the columns longitude and latitude. We can check now, did this change the projection of our data? No, it didn't, because we just converted it into a geodata frame. So what we need to do is first set the coordinates reference system for the company's geodata frame. And in this case, it is latitude longitude system that has a particular code and a 4326. We will then use the company's GDF to CRS to set the company's coordinate reference system to the reference system of the German map. And we will then see whether or not our conversion was successful and whether or not our geodata frame now has a coordinates reference system. And it does. And now we can plot the data on the same map. We have the old map that we have previously drawn of the German election districts. And we also have a plot of companies. And here it is. As we have seen already from that simple scatter plot, German companies, or the headquarters of German companies, are located mostly in the west and south of the country. And finally, we will show you some more complicated applications of Geopandas in testing some sort of hypothesis. First, we have uploaded a document of elections data that we have previously cleaned and created and filled with the coordinates reference systems and so on. You can see the file here. And in many ways, it is similar to the data frame we have previously used. So it has the voting districts with their numbers, the names of the voting districts. But here we also have the percentages of votes for several parties, as well as the maximum percentage for a particular voting district. In this case, the highest, or the highest percentage was 39.9. and it belonged to the Greens. We, of course, also have a column on geometry, and these are geometries of the election districts. And now we can plot the voting percentages per party, and we decided to make several subplots for 6 different parties. We can go through the syntax for one of those. We just call the plot on the data frame. We specify the axis, or the location of our subplot, the column that contains the data, in this case the Greens. We show the legend, and we color the map, this particular map, in shades of green. We also set the title. Running this will give us a full map of voting results in Germany. And here it is. We have maps for Greens, who have won mostly, or been winning mostly, in the West and East, Die Linke, who had some success in the east of the country, and AfD, who had a bit more success in the east of the country. and SPD then in the west and north, CDU in west and south, and FDP with a strong pocket here in the south. We can also plot a map showing which party has won the most votes per election district, and we do it here. And here we can see that the strongest parties, the CDU and CSU, have been winning the most votes in the southwest and west. We can see that Greens have pockets in several areas. We can see that SPD was the strongest party in central and eastern Germany. And we can see this blue pocket of AfD here in the southeast. And for those who want to know more, we can use the previous map and the map on the German companies and plot them together and see whether or not there is a relation between voting and where the headquarters of German companies are. I don't know if you see the connection, but we thought that there is a pattern in which areas with more companies or more company headquarters tend to vote more conservative. That means the CDU, CSU. Greens do have some pockets around in those richer areas as well. But SPD and Linke and AfD seemed to have won predominantly in areas with less companies' headquarters. And that's it from today. Where to go next? For additional information on Geopandas, you can check the resources we've collected. There are also some popular data sets you can use to try out your own maps. And you can check some other libraries that can be used for visualization of spatial data. I hope you had fun with maps today.